Okay, so as promised, here's the video I told you I would make for you, kind of detailing a little bit better the process for solving inequalities with absolute value. Now we'll talk about this more in class, but if you wanted to get a jump start on what this all means, or if you wanted to reference back to that, you could feel free to watch this as many times as you need. Okay, remember that all these steps on the left side are available for you. I put a PDF document on the class website. You can print that out or copy it, whatever you need. In the meantime, if you look at example 4, we have an absolute value now, and the directions are a little bit different, and the way it's written right now, we don't really like that. We're used to seeing the absolute value on the left side, so let's go ahead and flip that just to make it more familiar to us. 2 minus 1/2 x then is going to be greater than or equal to 3/2. Now let's go to the directions. Remember, there's no first step. We're going to come back and add something for that later. The second step is to separate into two, and here's the key word, equations. I'm going to kind of ignore the fact that this is an inequality for the time being. We're going to account for that later. So I'm going to separate it into two equations. I like to use the arrows. The first one, remove the absolute value only, so that would be 2 minus 1/2 x equals 3/2. The second one, I'm going to remove the absolute value, 2 minus 1/2 x, again equals, and this time multiply the right side by -1. So that would be a -3/2. Directions say to solve each side, so if we go with subtracting 2 from both sides, let's see, 3/2 is 1/2. If I subtract 2, I get -1/2. And then to isolate the x, I'm going to multiply both sides by a -2. That'll get rid of the fraction and the negative. That'll give me x is equal to actually 1. Working with this one, same first step, I'm going to subtract 2 from both sides. And if we have -1/2, and I subtract 2, that's going to be -3/2 or -7/2, like those improper fractions. Multiply again both sides by a -2, and that gives us a +7. Okay, we use the answers that we get, that 1 and the 7, as cutoff values. What I mean by that is, well, let's go ahead and draw a number line. Almost straight. We put those numbers on the number line. Those are going to be cutoff values. You'll see what I mean in a second. First step says place open or closed circles on the number line depending on what the inequality is. So if you look up to the original problem or the second step, you see I have greater than or equal to symbols. That means closed circles. So I can put a closed circle on 1 and a closed circle on 7. Step B says pick test points in the regions formed by the cutoffs. So when I say the regions formed by the cutoffs, I mean if we were to take 1 and 7 and use those as literally cutting the number line, we would end up with 3 regions. 1 to the left of 1, 1 in between 1 and 7, and 1 to the right of 7. Now I just want to pick any number that falls in that region. I think the easiest one to use over here, and it could be any number, I could pick whatever I want, but a number that's less than 1, 0. 0, a lot of things will probably drop out of our, well, when we get there. In this middle region, I think the easiest number to work with will probably be a 2. And over here, I think the easiest number to work with might be an 8. And again, I could pick any number I want. They don't even have to be whole numbers, to be honest. Letter C says shade only the regions whose test points to make the original inequality true. So go back up to the original inequality. Not even this one, although that one would work. I usually go back to what's in ink so I don't make any mistakes, just in case I copy this incorrectly or something like that. And I plug in the values. So first, let's use this region on the left, the one that we picked 0 as a test point for. And I'm going to plug it into this original problem. If it's true, I'm going to shade that region to the left of 1. So if I plug in 0, 3 halves stays 3 halves. Is that less than or equal to, well, let's see. If I plug in 0 for x, 0 times 1 half is 0. 2 minus 0 is still 2. So it's the absolute value of 2, or just 2. Since this is true, I am going to shade the region where 0 came from. So this left side is going to be shaded. And I also have the closed circle. Then I would do the same thing with 2 and with 8. Rather than spend all that time doing that, you can try that on your own. If you plug 2 in, you should find that the inequality is not true. If you plug 8 in, the inequality should be true. So we already have a closed circle here, and I am going to shade the region that comes from, or that 8 came from. And for the time being, you're just going to have to trust me. That's pretty much our process, but we always have to come back. Remember, x equals 1 and x equals 7 are not our solutions. So we go back and we would write the inequalities in the interval notation based on what our number line looks like. So we could forget about 0, 2, and 8. My inequality is going to be x is less than or equal to 1, or x is greater than or equal to 8. And my interval notation is going to look like negative infinity to 1, the bracket, and 8 to positive infinity. Okay, you can ask me questions on this tomorrow. Just kind of watch the video until you get it. In the meantime, but that's a second option that you have. Remember, you always have the option of using the first method, but if you're not really into separating your inequality, this might be the best bet. Okay?